Hello and welcome to OSGi Past, Present and Future. This is a presentation delivered for the OSGi Community Event in September 2011 and is delivered by Alex Blewitt, also known as Al Blue. All presentations need to start with small print, so here's mine. If you can't read it at the back, then basically all it says is that the opinions in this presentation expressed are my own and not of anyone else or any employers. Various trademarks and service marks are properties of their respective owners, and as said, the quality of this presentation may go down as well as up. So with that, let's start off with OSGi in the past. A long time ago, before OSGi was an acronym, before Java 1.2 had been released, and when people still thought Swing was great, JSR 8 was proposed. And JSR 8 was supported by IBM, Ericsson and Sybase at the time, and even Sun Microsystems. And the purpose of JSR 8 was to develop the Open Services Gateway specification. Now, it was proposed back in March 99, but it didn't last that long. It was withdrawn in May 1999, for reasons that I'm not entirely clear of. However, what that meant was that OSGi Release 1 came out about a year later in May of 2000, and then OSGi Release 2 about a year later in October 2001. And then since then, we've had OSGi Release 3 in March 2003. And then, not a great deal happened. But what happened next would change the course of OSGi's history. The reason is that Eclipse 3.0 switched to an OSGi-based runtime. Prior to Eclipse 3.0, there was a plugin model that allowed you to consume plugins, but it wasn't very dynamic, and it was something that the Eclipse maintainers at the time didn't want to have to maintain going forwards. And so in June 2004, fact says how just when you thought you were beginning to understand how it worked, it got replaced with the Open Services Gateway Initiative, OSGi. Rather than creating a derivative, building on top of what OSGi was and forking it, they decided to use it as is, but they did contribute some of those features back into the OSGi spec, such as the well-loved and admired require bundle. It was also the first time that many people had ever heard of OSGi, including myself. Since then, OSGi has been going on from strength to strength. OSGi Release 4 came out in October 2005, with many of the features that Eclipse 3.0 and Eclipse 3.1 needed to have in. It included additions to require bundle, to be able to have data added to objects in the form of fragments, and to be able to have singletons within the interface. Importantly, for IBM's case and other downstream developers for the IDE, it also had localization built in as well. But that wasn't it for OSGi. OSGi 4.0 mobile spec came out a year later in September 2006 and was then codified in JSR 232, the Java Standards Request process. OSGi 4.1 came out in 2007, which didn't really have any significant changes other than it was bounded, rubber-stamped JSR 291. And the reason for having those JSRs in there was at the time there were some other proposals, JSR 277 for example, and JSR 294, that were looking at modularity, and it was felt that having a JSR referencing an existing implementation would be a good way of moving forwards. OSGi 4.2 came out in September 2009, bringing some new features, for example the ability to launch frameworks from a standard interface and the service tracker for being able to detect when services come and go. 4.2 Enterprise came out now almost a year ago in March 2010, included an extension to declarative services, or a difference to declarative services called Blueprint, largely based on how Spring components work, and remote services for communicating between systems. earlier on this year we had the OSGi 4.3 release, and that had some new features to deal with generics of the OSGi framework itself, new hooks for dealing with weaving and service loading based hooks, and capabilities, a more generic way of expressing requirements between bundles. As for the OSGi Enterprise spec, we'll see another release of that in the first half of 2012, which is going to include improvements to JPA and to OBR and to the way subsystems are designed, probably to coordinate with the EclipseCon and DevCon that's happening in March of next year in Virginia. And so that takes us up to the present. OSGi has got a wide adoption in a whole bunch of Eclipse-based IDEs, whether that's IBM WebSphere Studio, MyEclipse, Rational Software Architect, or Eclipse-based rich client platforms such as the NASA rover tracking tool, the Mylin TaskTop, BERT Report Designer, or indeed IBM Lotus. But it's not just a client-side technology. In fact, the biggest users of OSGi, or the biggest growth of OSGi, has probably been on the server side, whether that's into direct servers like Glassfish, WebSphere, JBoss, SpringDM, or Virgo as it became, Jonas. All of them have adopted OSGi as the core runtime mechanism that allows you to hook these things together. And they've also been present in developer tools that people use on the server side. Atlassian, Confluence, and Jira both use OSGi as their plugin model, and of course Mylin talks to various systems as well. But let's not forget, the original home of OSGi was the built-in telematics and smart home systems, the kind of embedded gateway systems that are still using OSGi today. In fact, at the OSGi event, Deutsche Telekom announced Smart Connect, which they had released at IFA at the beginning of the month, and that's proposed to have an OSGi runtime which allows you to have OSGi components in various household devices such as fridges, TVs, washing machines and the like. And yet, OSGi isn't everywhere. IntelliJ has got its own custom plugin system, NetBeans uses a proprietary modules plugin, and Java 8 is going to invent its own way of doing things again. So why is everyone avoiding what is known as a proven technology? Is it lack of knowledge? Is it lack of marketing? Maybe a lack of support or a lack of tools? Well, I think one key problem holding things back is called the Omega problem. And the Omega problem is the fact that OSGi projects are named in Greek by geeks. The names themselves are usually meaningless on their own. They could be part of a set, like members of the Zodiac, or it could be based on Greek letters. But the key problem is that they don't usually stand out and explain what the project is. So when you're trying to sell this to someone and say, oh yes, you need to download Eclipse Virgo, or you need to download Eclipse Apache Carafe, it's very difficult for them to actually know what it is that they're downloading, and this unnecessarily increases the learning curve for new learners. So here's a bunch of good names which people have. Spring Data, Spring Web Services, Spring LDAP, Spring Social, Spring Batch. All of those things you could probably take a guess at what they do, even if you didn't actually use those things before. Apache generally has good names as well. Commons Lang, Commons IO, Commons Collections are all Java-defined libraries. Apache Directory Server is an LDAP-based server, and Apache Regset provides regular expression processing. All of these things you probably immediately know what they are from the name. And on the other hand, we have a bunch of bad names. And these bad names include things like Eclipse AZ0 through 9, Epsilon, Gemini, Libra, Virgo, Orion, Orbit, Sphinx, Papyrus, Phoenix, and Sequoia. All of those are Eclipse projects, yet none of them actually say what they are. And if you're not already familiar with those tools, then it can be a confusing set of names to know which ones you're supposed to know about and which ones you're supposed to look into. It has to be said that this problem isn't limited to Eclipse. There are also bad names in the Apache side as well. Apache Aries, GoGo, Carafe, Sigil, Tuscany, none of them really explain what it is that they do. And yet some of those are significant in terms of how we run. For example, almost all of the runtime engines use Apache GoGo as the shell for being able to interact with the system. And even Eclipse can use Apache GoGo as the shell as well. So the problem is that we need to fix how we refer to these tools rather than trying to come up with a new name that fits in with the Zodiac sign. It's really taking the pieces. So, when you're starting off with OSGi, there are in fact 5 levels of OSGi that you go through. Denial, anger, bargaining, depression, and then acceptance. In the first stage, denial, you have comments like, OSGi, that can't possibly work. Or, that's written by IBM, right? Or maybe you have the tortuous, I use IntelliJ, IntelliJ isn't Eclipse, Eclipse uses OSGi, therefore I don't use OSGi. And if you work with MuleSoft, you come up with comments like OSGi is too complex for mortals to understand. The second phase is anger. You get messages like, why can't I see this class? Why am I getting class not found exception? I can see it, it's on the path. These two classes have got the same name, but yet they're not equal. Why not? Or the famous, why can't I see javax.swing or com.sun.misc? And of course the infamous, why doesn't hibernate work? Once you've worked off your anger, you then get into a bargaining stage. Please tell me why this uses constraint fails. If we start up the services in this specific order. Why does this bundle work in Equinox but not in Felix? Oh, please let there be a Stack Overflow answer for no class def found error. If I put resolution equals optional, please just start. You then move on to the depression phase, when you try and figure out how to load a JNDI driver or how to use JNDI references. All of these things which are trivial to implement and trivial to use within a Java runtime seem to fail when they move into the OSGi element. You have questions like, how can you get your custom log4j logger to work? And because log4j uses dynamic class loading, then it fails to be able to instantiate custom loggers. Finally, you then move on to OSGi acceptance. You have a sudden dawn of understanding of how bundles work and how class loaders work. You see how services can be connected together with declarative services or Blueprint or another dependency injection service. And you can use remotes to talk to other systems. You can dynamically upgrade code in running servers. And then finally, evangelize OSGi to others, either by tweeting about it or by giving a keynote at a community event. So where are the module systems that people use today? Well, this uses something called the Charters Modularity Maturity Model. You'll find information of that on the OSGi wiki, but it was something that Graham Charters announced in the same OSGi conference. Level 1 is ad hoc modularity, where you're really not doing modularity at all. Level 2 modularity is when you're referring to artifacts by name. Level 3 modularity is when you're referring to artifacts by abstract requirement, such as package requirements or other capabilities. Level 4 is when you reach loose coupling by defining your system in terms of services rather than in terms of dependencies on artifacts. And then devolution and dynamism comes in where you offload your acquisition of these services into a repository and be able to stop and start things as they go. So let's start the race off and find out where we go. So roughly speaking, the common build tools of Maven and Ivy are really level 2 modules. They refer to artifacts by name and version. On the right hand side of the screen, we've got OSGi, which provides the full dynamism stack. And we've got a tool called POJO SR, which kind of fits into the middle of this. POJO SR is a Java library that allows you to run code in a modular way, but still be able to take advantage of services to be able to pull things together. However, unlike OSGi, it doesn't support the class loader bundle separation, and as such it fits neatly into the middle stage of these things. But this highlighted circle is really the Goldilocks zone of people who are trying to move off Maven and Ivy to be able to have a more dynamic system and yet not have to go through all the way to the OSGi strict compartmentalized modularity and dynamic model. Really, it's just a way to help people to cross the chasm from one side of the pure Java to the OSGi frameworks on the other side. Now, a lot of people are developing systems using microservices, and microservices really allow you to build modular applications. Essentially, they're just OSGi services, and the only reason for calling them a new name is to distinguish them from heavyweight service-oriented architecture services like being built in WS Death Star. And instead of thinking of a system as being a set of bundles, you can think of them as a set of interconnected services instead. And so you can have diagrams which allow you to explain how your systems consume, register, and listen to services in order to be able to define your system rather than at a strict module relationship level. And it allows you to put complex diagrams together in terms of how things fit and be able to represent and communicate that as a very high-level view of the system rather than being able to do it manually. Now, this would be a very useful diagram to get out of an existing system if we had the tools that would allow us to generate diagrams like this. Unfortunately, at the moment we have to generate these diagrams manually. And this brings us on to the POJO service registry, or just POJO SR. There's a wiki page on the OSGi wiki that has some more information about where to find out links from this. But essentially, the POJO service registry allows us to have a microservices-like view for Java that isn't fitting into OSGi. And it allows you to use the same primitives for being able to access services, but without having to have the class loader separation, which allows you to hide classes from one side to the other. So you don't implicitly get any issues with no class def found error, and the existing systems like Hibernate can continue to work. It's also a good stepping point to allow you to move on to developing a system which is built in terms of services, because you can start it up, you can hook all of these classes together, and then you can build forwards. However, there are some issues. The POJO service registry doesn't use the same namespace as OSGi because it's trademarked, OSGi is trademarked, and it's not a standard OSGi spec. But you can still use declarative services for being able to wire up services. So if you built a system and you've expressed its constraints in terms of declarative services, then you can hook those together and make those available as well. And the goal would be able to decompose your app without needing to have to use any OSGi specific code, and you can just hook your system together using declarative services. There's more information at the project page listed below, and also in the OSGi wiki itself. The enterprise spec has been coming a long way as well. It provides primitives which allow you to load database drivers. You can have data sources that are acquired from a factory. You can map objects with the Java Persistence API and include those within transactions to be able to hook things together. And they can all be hosted within an OSGi runtime. Now, the first enterprise spec came out with release 4.2, and that came out a year ago in March 2010. There's a new release 4.3 enterprise scheduled for 2012, which is probably going to come out in the first half of this year on or around the OSGi DevCon that's happening in March. There are various implementations progressing for the enterprise spec implementations. Apache Aries is the sub-project on the Apache side that's implementing this, and Eclipse Virgo and Eclipse Gemini are the two Eclipse-related projects. Now, at the OSGi event, Tim Ward demonstrated a runtime of using enterprise Java beans in OSGi. This took an existing enterprise Java bean jar file, either using annotations or using XML, and provided an OSGi-enabled annotation scanner to be able to detect all of the EJBs that were running inside that code. What the additions that Tim made to the Aries class load JPA utilization was the ability to wire up these EJBs, and by hooking in an application class loader, it can add the open EJB classes which are required, and those JPA entities can then be mapped to databases outside of the JPA code itself. The databases are then hooked up with JNDI references in exactly the same way that enterprise Java beans are used in the future, and importantly, the transactions and context are managed by the container automatically, so that when you have the session enterprise beans or views registered as OSGi services, you can use and interact with OSGi from another OSGi component without actually knowing or indeed caring that you're talking to an enterprise Java bean. This is still a work in progress. For example, there's no J2EE security model, and the implementation is currently being developed in trunk, so it is not part of an official release within Apache Aries. But Tim says with the upcoming release of OpenEJB 4, a new release with Apache Aries will make this publicly available. Now, the other thing that OSGi needs is a standard repository system, because more than anything else, a repository is what makes modular systems. And Maven, I think, is the poster child in the Java world as being the go-to place to be able to get assets and consume assets. It's the de facto standard and replaces prior systems like the giant Java tree that existed to provide Java modules. You only have to look at the success of other languages to know that really this is the bootstrap mechanism that gets things else. Perl has got the comprehensive Perl archive network, or CPAN. Python has got easy install, so if you wanted to install Mercurial, then you could do easy install HG, and that would put in Mercurial. Although if you are looking into distributed version systems, you're probably better off looking at Git. Ruby has got gems for being able to develop and host gem code. If you want a wiki-based system based on Git, then you can do gem install Jekyll, and that will pull that down. Linux distributions have long had packaging sites that have tools like RPM and APT and Yum to be able to install things. So what does OSGi have? Well, OSGi has got two technologies really that are used to it: the Eclipse P2 and the OSGi OBR. Hang on a minute, there's a typo on that slide. The Eclipse P2 guys really get annoyed when you mistake their name. So Eclipse P2 is the mechanism that's used by Eclipse to be able to have updates pulled into an IDE runtime. It replaces the aging site XML update sites, and it has a metadata dump which has the contents of the manifest, so that the resolver doesn't need to download everything to know whether something's going to work or not, but yet it can still reach out and be able to get things. Unfortunately, it's a very chatty network protocol in terms of being able to pull things down, and the files themselves aren't really optimized for network transition. And there's other problems like it being non-trivial to mirror. OBR, originally the OSGi bundle repository, is still a work in progress on the enterprise group, and hopefully there will be some specifications within the OSGi 4.3 release that actually finally standardizes OBR that people can agree on. At the moment, therefore, it's not widely available, and like P2, it's by and large represented by a single file, which is the data of all things. Current implementations of OBR have that as being uncompressed. The hope is that the enterprise group, when it comes out, will mandate compression of this file. Of course, you can install bundles manually. You can do install HTTP or some other URL to be able to pull a bundle down, but that doesn't necessarily resolve everything for you. In terms of the implementations of these repositories, well, P2 has probably got wider success, if only because it is, for want of a better word, a de facto standard, and that it's used by a number of different players. So Eclipse P2 update sites are used for not only providing content to end users, but it's also an implicit part of the build chain as well. And the Eclipse Marketplace is really an aggregator that allows you to bring together multiple P2 update sites and present them in a single way. What actually happens with the marketplace is it's really more of a metadata mediator. So you go and do a search for something, and then it tells you which P2 site to go to. For OBR, Apache Felix has supported OBR for a long time. There's a list of files of the OSGi representation, and there's a Spring Source OSGi repository as well. And it's worth mentioning, though, that Maven Central has got some OSGi content as well. If you have an OSGi bundle, you can drop that into Maven Central, and it will still be resolvable via the artifact name itself. Nexus Professional has got the ability to have an expose of OBR content. So if you put in an OSGi enabled bundle, then you'll get an OBR file that comes out of it. And there's some work in progress called the Nexus Bundle Maker, and what that does is it allows you to wrap existing non-OSGi jar files to be able to consume content. And if you find out the documentation from there, you'll see a work in progress on the Sonatype grid that does a wrap-on-demand service for consuming non-OSGi bundles. It's also worth mentioning the Ops4J PAX utilities, and the Ops4J PAX utilities are something that should be really more widely used, I think. One of them is provided is a wrap protocol handler, and that allows installation of jars and auto wraps them to provide the correct OSGi bundle headers. So instead of just doing install HTTP on the command line, you would do install wrap : HTTP : and then the path to where your jar is located. Another one that's incredibly useful for consuming from Maven is the MVN protocol handler, originally part of the PAX URL Maven, but now replaced with PAX URL Ether. And Ether is the new resolution engine that's part of Tycho and is moving to be an Eclipse project. And the Maven protocol allows existing bundles of Maven via the Maven repositories that exist, and they have the group ID, artifact ID, version number that you can use to come down. Of course, those aren't the only things that the PAX utilities provide. There's PAX Exam, which allows you to do automated testing. There's a logging mechanism, which allows you to do essentially a mediator between the OSGi logging and Log4j, SLF4j clients, so that if you've got a client that has those existing code bases already, then you can bring them into the runtime, and they will then delegate their logs to the OSGi logs. And PAX also provides something called PAX Runner. That's an ability to be able to create an OSGi framework and start some code in there. And I think what's really needed with OSGi is some kind of universal launcher that allows you to download bundles, execute some configuration options, and bring your system up from an empty starting point. And so that brings us on to the future OSGi repositories are really going to need to provide modular repositories, because an all-in-one download of metadata simply isn't scalable over the long term. If you have a minor update to one artifact in the repository, then you have to download the entire file again. We also need to provide ways of dealing with efficient repositories. For example, if you're stealing the contents of all of the manifest data within each of the index entries, then it's obviously going to balloon out of size. In the case of P2, P2 contains multiple redundant copies of the Eclipse public license. In fact, almost a third of the total index size is repeated elements for EPL. It also has some fundamental errors in terms of printing out pretty printed XML and not using standard compression tools to be able to reduce the size of it. Hopefully, the OSGi standard due next year are going to address some of these problems before the release. Here's an example of an Eclipse P2 content file, which as you can see is based in fairly XML, and as you can see, it includes whitespace and other elements inside that are strictly unnecessary when you're parsing an XML file. There's no real reason to have those in there. Similarly, there's no real reason in a tree-oriented file like XML to tell it that it's got two properties, because that's an implicit property of the XML file itself. And we really don't need to see the same Eclipse Foundation software user agreement on every single artifact that's hosted in there. In the Eclipse 3.7.0 platform update site, the EPL full text occurs 101 times, which explains whenever you're doing a check for updates in Eclipse why it's so slow. Let's just put that into a pie chart. The actual useful data that's stored in a P2 repository is about just over 40%, 2/5 of the content of that. A significant chunk, almost as much as the useful data, are then repeated copies of the Eclipse public license. Then there's unnecessary whitespace, which doesn't make any difference to the code but does slow it down. And then finally, there's repeated uses of telling XML how many elements it's got in there. Also, if we were using the correct compression technologies, we'd be using gzip to be able to compress the file down rather than a jar file, because the jar file doesn't compress it as well. It's also unnecessary if there's only one file in there to be able to use a jar or zip file format to be able to store it in, when you could just use gzip to be able to cut the contents together. So these are problems that we're going to need to solve with OBR, and if we do solve them, then hopefully it'll work. The reason why repositories are important are because of the cloud, and cloud systems are increasingly important both in the world and also in the OSGi runtime. What the cloud allows us to do is have OSGi management across multiple machines so that we can spin up and install new OSGi runtimes and be able to hook things together. The reason is that the cloud is all about virtual machine technology, and virtual machines allow you to spin up as many copies of an operating system on a physical piece of hardware as you want. But having one process or one system per physical machine is a very wasteful way of being able to develop these things. And so what typically happens at the moment in Amazon EC2 or Google AppSpot, for example, is that you host a single application within an entire virtual machine runtime. And this obviously isn't going to scale when you have lots of little systems that be able to put together. With repositories, OSGi will allow us to solve an install-on-demand system so that we can view our virtual machines as being orthogonal to the systems that be able to run on them. And you can then spin up the VMs, you can install the components on there, pull them down, and then you can either have one or many systems running on the same machine. In addition, the OSGi with remote services solves scalability. If you want to be able to scale out, just spin up another machine, run a whole other set of instances on there. OSGi remote services will just pull it together and hook them in. And the idea is that once you've got a base virtual machine with an OSGi runtime bootstrap engine, then you can easily run up and install these things. And I think if we do have a universal bootstrap process that can provision, deploy, and configure elements, then we have a very good starting point for being able to build grid-based systems across clouds. The other thing that I think is going to be key for the future is interoperability with legacy systems. OSGi remote services are very much a way that's going to be used in the future for being able to have communication between OSGi systems. However, it only really works if OSGi exists on both sides. Typically, though, there are legacy-based APIs which you need to hook into. In some cases, they might be an RMI service that allows you to pull things together, or you might want to be able to communicate with an OSGi server who's provisioning that you don't control and have no control over the source code. It's also useful to be able to have REST-based APIs for being able to hook Java clients together, or indeed for integrating with JMS-based messaging systems to be able to consume or provide services. If we've got all of these interoperability systems in place, then that will allow us to evolve systems by not requiring you to upgrade both endpoints at once. We can have an OSGi runtime talking to a legacy system, or we can have a legacy system talking to an OSGi runtime, and you can then improve the situation incrementally from there. We're also going to see some enterprise improvements in the future as well. Right now, if you want to look up a data source, you have to look it up under OSGi:/service/java_x.sql.datasource, which really isn't helpful because it requires you to go down an OSGi-oriented namespace model. Most non-OSGi code looks up namespaces by using JNDI lookup JDBC/data source name, for example. And I think what we need to do is make it easier for an OSGi runtime to wire up data sources so that they are available in clients like that. We also need to fix JPA. It inherited some incredibly bad practices, probably from Hibernate, but there's no real reason why JPA should have anything to do with usernames or passwords in the actual JPA bundle. It's a complete layer variation. There's no reason why the JPA bundle needs to instantiate the data source. Rather, it should consume it as a service from somewhere else. And I think the new OpenEJB Aries project is going to make migration easier for people who've invested time in tools, in technology, and people used to being able to do things in that way, to allow them to migrate existing code without changing and then be able to host that with inside an OSGi runtime. The other thing to look out for in the enterprise spec is the features, apps, subsystems that are coming out. And this is going to be a way of grouping together features in an OSGi runtime neutral way. Eclipse has always had the problem that it's viewed features and bundles as two different things rather than trying to relate them at all together. And the OSGi features within the subsystem spec are going to allow us to have the same way of representing features that could be used in a future version of Eclipse and for Aries and for Virgo and all of these other servers that need to be able to install multiple bundles at one time. They also have a proposal for how you could represent grouped or composite systems and applications as well, in addition to providing means to allow you to install single systems. Having some of these features available is going to make management of large systems easier and may in future be integrated into OBR as capabilities, and that's part of the Enterprise Expert Group work, which is due sometime next year. As far as tooling is concerned, there's still room for growth being able to deal with it. We've actually got quite a rich set of tools at the moment. Maven has obviously been able to build OSGi components for some time. That's what tools like Felix use for their build systems. But Tycho is increasingly taking over from the PDE and Ant-based builds that were used in legacy build systems in Eclipse. Quite a lot of projects, as they're moving over from CVS and Subversion to Git, are also choosing to move their build platform over to Maven so that they can have a repeatable build system and be able to generate content. BND tools is another way of building tool code, and that's something that Neil Bartlett's been working on as a means of creating OSGi enabled code easier. But it's not just about the development. We can also have tools for being able to do reporting as well. For example, managing semantic versions automatically so that you don't need to worry about how they hook together, or PDE baseline analysis. And indeed, if you've got something where the bundle hasn't built, then what happens if it should be included again? Should it be changed or should it be just left as is? And finally, if we're moving on to microservices, then we ought to have some tools that think about services rather than think about classes and bundles. Can we concentrate on developing a system in terms of services and then be able to materialize these in the form of bundles? Is there a scope for model-driven design? I think all of these things are opportunities for growth within the OSGi space. And really, we've got to focus on making it easier for bridging the gap. Being able to come from a plain Java model where you're maybe on a level 2 module system and you want to be able to move up through the ranks to get into the service-oriented architectures and to be able to get into the dynamism. I think dependency injection can help in this regard. Eclipse Susu, based on Google Juice, provides JSR 330 injection annotation support, and that's something that developers are very much aware of with existing systems. Sisu is used in Tycho, Maven and Hudson, and is now an Eclipse-based project as well. Importantly, Sisu supports both OSGi and non-OSGi runtimes, so that you can have services that get injected, but not necessarily have a requirement for saying where they are. And so, it might be useful for being able to combine that with other tools, such as the POJO SR that we talked about. If you're going for migrations, then obviously get off Hibernate. Hibernate is one of the worst offenders in the OSGi world, and move on to others like JPA, either through Eclipse Link or Aries, or indeed the OpenEJB stuff that we talked about here. If you're using JaxB, that's another tool that has known to be very badly behaved in the communication world, and you're much better off at looking at well-designed technologies like Restlet that also provide OSGi support in order for a migration path. And if you're building Spring applications, then the recommendation is to move into Virgo first of all, because that's got a lot of Spring-based stuff. But given that Spring, by and large, provides you with the same tools that OSGi Blueprint will provide you, then you can look at reducing the Spring context requirements and replacing them with vanilla OSGi services like dependencies on Blueprint, so that you can then have the ability to run on multiple different systems. And so with that, I'd like to conclude this presentation. OSGi is still evolving, and the core part of it, the modularity side, is well understood, but I think what is coming up in the future is really consideration to develop in terms of microservices. Enterprise Java is a good starting point for being able to hook these together, but realistically we've got to solve the repository problem if we want to be able to unlock and enable some of the cloud-based systems that follow afterwards. We also need to focus on being able to compose systems at the higher level, and rather than having to go down to the granular bundle by bundle installation process, we need to be able to group these together into higher level systems and components and be able to install those within our runtime systems. And finally, we need to focus on ease of use. All of the OSGi spec is very well defined and provides some very well thought out and consistent APIs, but we need to be able to build on top of that to be able to make it easier for people to get on board and to use these systems. As for what the OSGi community can do, the OSGi Alliance has obviously got its work cut out dealing with specifications and moving things like these forwards, but there's still many jobs that need to be done. Education, providing the right way of doing things, success stories, advocacies in books, blogs and tweets, OSGi in practice or OSGi in action, patents of modular architecture. All of these things are ways that we can get the message out that actually developing for OSGi is often easier than a corresponding Java runtime, but also providing people the handheld translations to go from a system that they have at the moment to something that they want to go forwards. And I think it's also worth pointing out that innovative solutions like PAX and POJO SR came from outside the OSGi community, and indeed tools like BND tools and BND itself are ones that aren't OSGi mandated or OSGi spec systems. They are just ways that we can build these tools together. And finally, on a personal note, I'd like to ask people to join in and help out with the OSGi wiki, because that's really aimed to be the go-to place for the OSGi community to go and add components, provide help. And so for those who are interested in learning OSGi, we have a single place that they can go to, rather than having per project wikis or per foundation wikis that split this information up. Only you can make this happen. This has been OSGi Past, Present and Future by Alex Blewitt, recorded on the 21st of September for the OSGi Community Event in Darmstadt. Thank you for listening.